vector addition. So we have gone through the resolution of a vector. For example, let's say there is a vector A in a plane, then we can resolve the vector A into its components as follows. So this way we can resolve a vector A. We have done this thing in our previous video. You can get the video from the same playlist. So, and let's say there is another vector in a plane. We can write in terms of its components dx I cap plus dy j cap, where I cap and j cap are unit vectors along x-axis, positive x-axis and positive y-axis respectively. So if we want a resultant vector by adding these two vectors, then we can do it easily. We can add these vectors component wise. For example, we can add the components along I cap, as well as we can add the components along j cap separately. Then we can write as follows: ax plus bx. These two are components of vector A and vector B along I cap, and then we can write ay plus dy j cap, or simply you can say this is Rx I cap and Ry j cap, where Rx is the component of vector R along I cap and Ry is the component of vector R along j cap. And after adding these two vectors, we see Rx is nothing but ax plus bx and Ry is nothing but ay plus dy. The same argument we can carry forward to get vector addition in 3D. So, and then we have resultant vector R, which will be x plus bx I cap plus. So this is the resultant vector we get after adding vector A and vector B. And we can see here this part is Rx, that is x component of vector R. This part is Ry and this part is Rz. We can check it geometrically. What does it represent? This is vector A, and let's say I should use different color. So let's say, yeah, this is vector B. So we have this magnitude as dx up to here, and this magnitude, the projection of vector B on to the y-axis, so it comes up to here. So this magnitude is dy, and similarly ax, this length actually, and up to here this is a y. So what we are doing, we are adding this ax plus bx to get the resultant vector along x-axis, and this ay plus dy we are getting along y-axis. So these two are components as we have written here earlier here. So the same argument we can carry forward in 3D also. So we can do one thing here. We can add one more component z, and then we can get projection onto z-axis, and then we can add that component also in case of 3D. So this way we can add vectors to get resultant vector in terms of their components after resolving those vectors into their components. So this is one way. Two vectors can be added in another way also. Let's say we have two vectors. As we know, we can translate a vector parallelly. If we are not rotating it, if we are not changing its length, then the vector will be the same. Whether I am writing this vector B here, or without rotating or changing its length, we can just translate this vector here also. So this is the same vector. Let me clear it. This is the same vector B. So let's say there is angle theta between vector A and vector B. So this angle will be theta. Okay, let me make the diagram more clear. Let's say this is resultant vector R. So okay, up to here vector B. Just forget about this one. So we have vector A, vector B, and vector R. Now, if we want to get magnitude of vector R, as well as we will get direction also. So how can we proceed to get it? In another way, as follows. Let's say this angle is theta. So we can draw a perpendicular from here. We can extend this A to meet the perpendicular at point. Let's say this point is O, this point is, let's say this point is P, and this point is, let's say, Q, and this point, let's say, M. So now we have triangles, and based on their sides, we can get the magnitude of this vector R. Okay, let's say the length of OQ is R, the length of AP is A and the length of PQ is B. And then we can say this QM, let's say L. So in triangle OQM, this triangle, you can use Pythagoras theorem, and then R will be nothing but OM whole square plus QM whole square, and these all things are under the square root. So this is the length of R. We can write hypotenuse equals to OM square plus QM square and whole thing under square root. So what is OM? OM is nothing but OP. Up to here we have a known quantity which is the length of this vector A. So OP and plus PM. We can write it A plus M whole square, and then we have Q1. This one is Q1, which is L whole square, and this whole thing is under square root. Now we have to go for some trigonometric ratios. Let's say this M. We can see here, as we don't have M, we have only three parameters here which are known: A, B, and theta. A is the magnitude of vector A, B is the magnitude of vector B, and theta is the angle between the vectors A and B. So we have these three parameters only, and here in this expression we have M and L. So we can do one thing: we can convert this M and L in terms of A, B, theta, whatever we require. Let's see how we can do that. So in triangle PQM, this is the triangle PQM, we can say sine theta equals to L by B, and cos theta equals to M by B. So from these two, we can write M equals to B cos theta, A plus M equals to B cos theta, and L equals to B sine theta. And then we can proceed. So here we will get A square plus B cos theta whole square plus 2AB cos theta. And then we have B sine theta whole square. So we have next thing under root A square plus, we can take B square common from these two terms, then we will get B square, and from here we will get cos square theta, and from here we will get sine square theta. So this way we can write, and then remaining term is 2AB cos theta, and then we will have A square plus B square plus 2AB cos theta and whole term under square root. This is the magnitude of vector R, and we call it triangle law. There is another law which we call parallelogram law, but that law is not different from this one. At the end you will get the same result, just making some other expressions. You can just shift this vector here, vector B, and then you can say that the parallelogram has this diagonal, and this diagonal will be the resultant of addition of these two vectors. So eventually that will come to the same result. And now we want to get the direction of the vector. So for direction we have to take reference. So let's say this vector, resultant vector R, is making an angle alpha with the vector A. Then we can get what is alpha. And from this diagram you can see clearly. Let me change the color of this. Okay. So you can see clearly in OQM you can apply this thing: tan alpha equals to QM divided by this length OM. So tan alpha is nothing but QM. QM is this length L, and we have found it L equals to B sine theta. So this will be B sine theta divided by OM. So OM is OP, which is A, and plus PM, which is B cos theta. So after solving these things, as we have B, theta, and A, these all quantities we know earlier. So we can get what is the value of tan alpha, and from there we can get tan alpha equals to tan inverse of that value. So from this thing we can get the direction of vector, resultant vector R, in terms of alpha. That is the angle the resultant vector is making with the vector A. So this way we can add two vectors. And now after a little change, we can get subtraction also. Let's say we want to get A, vector A minus vector B. How can we proceed for that? Okay, all we need to do is to replace this vector B with vector minus B. So how can we proceed for that? Let's say this is vector A and this is vector B. So vector minus B will be the vector which has magnitude same as that of vector B, but direction just opposite to the direction of vector B. So this is vector minus B. So this is a very simple term. If this is vector A, So with equal magnitude and opposite direction, this vector represents minus. So we can get here, if this angle is theta, this angle will be 180 minus theta. So resultant we can get here. Let's say this is resultant vector S, and vector S is vector A minus vector B, or we can write vector A plus minus vector B, and then magnitude you can write resultant vector has magnitude of under root A square plus B square plus 2AB, and now we have angle 180 minus theta between vector A and vector minus B. So we can write here cos 180 degree minus theta. This will be nothing but A square plus B square minus 2AB cos theta. In the same way, we can get this angle alpha also here. So tan alpha will be nothing but, as we have done earlier, let's check it, b sin theta here, b sin theta divided by A plus B cos theta. And the only thing we need to do is we have to replace this theta by 180 minus theta. So we will get the result here, and I'm leaving it for you. You can do it easily. And then at the end, let's take these two terms. One, law of cosines. Okay, at the end, let's take these two things. One is law of cosines, and another is law of sines. So we have done this thing already, and yeah, this is also a form of law of cosines, and here this is law of cosines. And then coming back to the second term, law of sines. So we can get relation from the triangles here, and then we can use sine and get some relations, and that will be law of sine. So let me clear some part here, then we can proceed here. So before that, let's say beta, there is another angle beta. Yeah. Beta is the angle between vector r, resultant vector r, and vector v, and this is the angle. So you can check here, if this is vector r and this is vector v, let's say this is vector v. So this way vector v has direction, and this way vector r has direction. So if the angle between these two vectors is beta, we can write here angle beta, and vertically opposite angle, this will be beta. So that's why I have written here beta also. This is the angle between vector r and vector v. Now we can do one more thing here, and then we can get the sign relation. We can draw a perpendicular from point P to vector r, and let's say the point here is N. Now we have relations as, so first in triangle OQM, this way. In triangle OQM, we have QM equals to R sine alpha. And then in triangle PQM, we have this triangle PQM, we have QM equals to B sine theta. This is one thing. And second, in triangle OPN, this triangle OPN, we have this PN equals to, sorry, PN, this PN equals to, this PN equals to A sine alpha. And in triangle QPN, this one, QPN, we have PN equals to B sine beta. So B sine beta. So we have here R sine alpha equals to B sine theta. R sine alpha equals to B sine theta, or we can write R by sine theta equals to B by sine alpha. In the same way, we can write here A sine alpha equals to B sine beta, or we can write A by sine beta equals to B by sine alpha. And we can see here is B by sine alpha, and here is B by sine alpha. So if these two are present here, it means the left hand side of these two equations should be equal if the right hand sides are equal. So we can write R sine theta equals to B sine alpha, and then B sine alpha is equal to A by sine beta. And this way we have got law of sines. So in case you have any doubt, you can ask me in the comment section.